Hello everyone, I am Aaron Gabriel Dichoso, here to teach you today regarding basic vector operations and properties. So before we get started into that, what is a vector? Well, if maalala nyo, from different applications that we did, possibly sa senior high school, possibly may nakita kayong YouTube video or research or something, we would remember vectors as something that we use in physics. Diba, when we're computing, for example, force or acceleration, etc. In computer science, we see vectors in the form of parang sets, mga column matrices, where one part would have a specific type of data type, tapos another one would have some other kind of data type inside, parang ganon. Today, we are going to talk about itong representation of vectors natin, the geometric representation, wherein it is defined as an n by 1 column matrix. So for 2D vectors or vectors in planes, we would see it as such. And for 3D planes, we would have 3 by 1 column matrix. You can also represent it through this position representation, a directed line segment from the origin 0, 0 to the point xy. Ito yung usually nakikita natin to sa mga physics, etc. Ganon. Today, we are going to talk about two types of vectors, vectors in the plane and vectors in space. And we are going to talk about the various operations that we can do to these vectors. So first, let us go to vector operations in space. So here we have various operations written down for vectors. So first, we are going to have equality. Equality is defined if x1 equals to x2, then y1 is equals to y2 for these two types of vectors. Simple naman, no? So for example, if you have 3, 4, then it would also be equal to 3, 4. It's not equal to, let's say, 4, 3. Iba yun. Hindi naman din equal na 3, negative 3, 4. They're all very different vectors. As long as yung corresponding elements are the same, that is an equal vector. They are both equal vectors. Addition. Now, addition, na medyo self-explanatory din. Here we have two column matrices representing vectors, and we add them together by adding their corresponding parts. So dito yung x sa taas, they get added together, and yung y sa baba, they get added together. Visually, it would look something like this. Let's say may Cartesian plane tayo. And let's represent this x1, y1 as something like this, wherein we move a couple of steps to the left, a couple steps to the right. And let's say our x2, y2, our second vector would look something like this. Couple of steps to the z-axis, couple steps down on the y-axis. Adding them together would mean, and let's say our second vector would look like this. Couple steps here, and then a couple steps up, okay? Then the added vector, the summation of these vectors, can think of it as such. Let's draw it again here, just a smaller representation. Think of it as moving from the first vector to its end, and then from the end, dun sa dulo ng first vector, you are going to draw yung second vector. Okay? Medyo ganyan. Tapos from the origin, ibang kulay natin, from the origin to the tip of the second vector, you draw the vector connecting those two. So visually, it would look something like that. Okay? Scalar multiplication naman. Visually, it would look something as such. So if we tried an example, 3, 4 plus 4, 5, it would be 3 plus 4, 4 plus 5 is equals to 7, 9. Okay? Scalar multiplication naman. Scalar multiplication, that it is performed when we are multiplying a scalar or just a regular real number. It's not a vector. Parang number lang siya to a vector. So to do that, we just distribute the value of the scalar to each of the corresponding elements inside of the matrix. Okay? So if I were to say -2, 10, 20, you would just distribute that inside, and it would be -2, 10, -2, 20, and it would be -20, -40. Okay? Next, vector subtraction. Vector subtraction, it is similar sa ginawa natin sa vector addition, wherein each of the corresponding elements, you just apply the normal subtraction operation to them, di ba? Visually, medyo nakakaiba naman yung presentation niya. So there are two ways of representing vector subtraction visually. So the first method, the first thing I would do is I would draw, let's say, ito yung first vector natin. And ito yung second vector natin. We can visualize vector subtraction as such. First, we would draw the first vector. Then, we would draw the second vector. However, instead of pointing to that side, then we would draw the second vector. Then, imagine that we also have an imaginary vector here which corresponds to the lengths of yung red at saka yung green vector. Okay? So then, yung subtraction natin, it would be from this point, from the second vector, starting point from the second vector, going to the first vector. Parang ganyan. If you think about it too, vector subtraction is essentially just addition. However, we are multiplying the second vector by -1. Diba? So we can also visualize it as such. We can say that this is the first vector. And the second vector, instead of going this way, we go the opposite direction. So we can go this way. And then we would just point those two together. And we would have the same vector. Okay? Next, we would have direction and mag. Okay? Try natin example para lang mabilis. Let's say 5, 3 minus -4, 10. Your equivalent vector here would be 5 minus -4, so 5 plus 4. 3 minus 10, so it would be 9, -7. Next, let's move on to the direction and magnitude. Here, we are going to stray away from yung mga basic na operations. We are going to get a bit more complex lang. I'm going to show you how we get ano ba tong formula na ganito. And we'll test some different examples on using the formulas. So first, magnitude. Magnitude here refers to the length of the vector. So if nakikita nyo sa visual representation natin, there are two important attributes to a vector sa visual representation natin. Una, yung direction at which the vector is pointing. And pangalawa, yung magnitude or how long is the vector. So let's think about it this way. A vector can be split into yung two parts nga na nakasulat dyan, the x component and the y component. So first, yung x component, ito. And the y component is ito. Therefore, if we want to get the magnitude, we just need to find the length of this. Now that sounds very familiar, diba? Because this forms a right triangle. Therefore, we could use the Pythagorean theorem nung grade 8 pa. Tagal, diba? The Pythagorean theorem. Wherein, you can say here, sabihin nating magnitude na yan of A. The magnitude of A squared is equals to x squared plus y squared. You square root both sides, and you get magnitude of A is equals to the square root x squared plus A squared. To get the direction naman, there is a different way of deriving it. So it says here, let theta be the angle made by the vector A to the horizontal. So it can be represented as such. Say this is our vector. Therefore, theta would be this angle. Now, as established before, this is our x component. And this is our y component. So, if you would think back to geometry, trigonometry pala. Trigonometry, we have this Sokotowa rule. Sokotowa cheat, parang gano'n. And if you would remember, using that, we would get tangent theta is equals to opposite, yung opposite side niya, which is y, and x, which is this, adjacent. Therefore, theta is just equal to arctan y over x. Where can we apply yung magnitude and direction? We can actually apply it here sa unit vector. So a unit vector is a vector with a magnitude of 1. And for example, if meron kang vector na hindi magnitude ay 1 and you just want to focus on the direction at where it goes, you can get the unit vector instead. So getting the unit vector of a vector with the same direction as of the other would just be A divided by yung magnitude niya. Let's say we have a vector here. A 3, 4. Ganun kasimple lang. So for the sake lang of example, then I'm also going to get its direction. So A, magnitude of A would just be equal to, sinabi nga natin, square root of x squared plus y squared. So it would be 9 plus 16, which is equals to square root of 25, which is equal to 5. So that is our magnitude. Our direction naman, yung angle theta, would be arctan y over x. So our y here is a 4, our x here is a 3. And if we input that into our calculator, I would get Okay. I would get a value of 53.13 degrees. So, medyo ganyan. That would be, visually, it would look something a bit like that. Now, if we wish to get the unit vector of this, we would divide the vector with the magnitude. So by doing so, say unit vector A is equals to A over 5. So that is 3, 4 times 1/5. So that means our unit vector A is equals to 3/5, 4/5. Additionally, we have some special unit vectors here. Yung I and J, which is just 1 on 1, 0, then 0, 1. And doon nanggagaling actually yung unit vector notation. Because if you think about it, if we just substituted the value of J here, it would be 1, 0. And for I would be 1, 0, and J would be 0, 1. It would be 0, 1. So that's equal to x 0 plus 0y, which is just xy. So similar lang yung it's just a different way of representing xy, yung geometric representation natin. Some properties that you need to keep in mind lang when working with addition and addition and scalar multiplication of vectors. So a plus b is equals to b plus a. This is just commutative property, basically. Parang ganun lang din. A plus b plus c is equals to a plus b plus c, quantities. So this is associative property. 0 plus a is equals to a. So where 0 is a special zero vector, tawag dito ay zero vector, wherein it's just the column matrix filled with zeros. A minus a equals 0. So that makes sense naman. If you subtract a vector by itself, you just get 0. Here, we can also distribute scalars. Dito naman, the vectors can be distributed to the scalars. And here, we can see that the scalars can be moved associatively. Okay? And finally, yung identity. 1 times a vector is always going to be the vector itself. Moving on, we are going to go into dot product. So dot product, or the inner product of a vector, is defined as such. So let's say A is equals to x1, y1, and B is equals to x2, y2. Then A dot B, yun yung symbol niya, A dot B, is equals to x1 times x2 plus y1 times 1, y2. So basically, you multiply the corresponding terms, and then you add, and then you add it all up. Try natin. Let's say A is equals to, paborito natin 3, 4, and B is equals to 5, negative 2. Then A dot B would then be equal to 3 times 5 plus 4 times negative 2. Take note that this, because of this operation, it would actually give a scalar value. Magiging scalar value siya, hindi vector to, not a vector. So this would give 15 minus 8, which is equals to 7. This, however, even though it's not a vector, it can be used in many different vector properties. For example, yung perpendicular and parallel vectors. Here, we can see that two vectors are perpendicular or orthogonal to each other if the dot product between of the two vectors is 0. They are parallel if yung magnitude of the dot product, absolute value pala, not magnitude, absolute value of the dot product is equal to the product of the magnitudes. Product of magnitudes. Or, pwede naman sabihin na A is equals to B times some number C. So parang yung isang vector, parang siyang factor nung other vector. If that is the case, then the two vectors are parallel. Let's say, ito naman, medyo nakakaibang example. Let's say we have a vector. Okay, so let's say we have a vector 4, 5, and we have another vector B, which has the value 10, x. So what value does x have to be so that, what value does x have to be so that A and B are perpendicular? Let's try that out. So if A is perpendicular to B, then A dot B is equals to 0, right? Therefore, A dot B is equals to 4 times 10 plus 5 times x has to be 0. Let's just solve this. You would get 5x minus 40 equals 0. 5x is equals to 40, and x has to be 8 for A and B to be perpendicular to each other. Okay? Now, how about if they are parallel? If A is parallel to B, then we can say that A is equals to C times some value of B. So we could say 4, 5 is equals to C times 10x. If we solve this, we would get 4, 5 is equals to 10c x times c. And here, makikita natin we have some sort of system going on, a system of linear equations. So we can do 10c equals to negative 4, x times c equals to 5. Now, you can either solve it like a matrix, but for me, I would like to solve it just the regular way using algebra. So 10c is equals to negative 4. C is negative 4 over 10 or 2 over 5. Now, let's plug that in. So we have negative 2 over 5 is equals to 5. Put that over there, and we would get negative 2x is equals to 25. X is equals to 25 over 2. So x has to be 25 over 2 for A and B to be parallel to each other. Other relationships that can be found using the dot product and magnitude are the angles between two vectors. So let's say you have A here and B and C. Let's try out the example given kanina. Let's say 4, 5. And let's say 10, let's say 10, 5. Ganyan. Let's say we have these two vectors and we'll try to find the variable, the angle between them. We will just use this formula, dot product A dot B over magnitude of A times magnitude of B. So dot product of A dot B. A dot B would be equal to negative 40 plus 25 is equals to negative 15. Magnitude of A would be equal to 16 plus 25. So that is 30, 41, square root of 41. Magnitude of B would then be equal to 100 plus 25. So square root of 125. We can factor this out with a 5. So we get 5 root 5. Finally, putting it all together, that means we would have cosine alpha would then be equal to negative 15 over square root of 41 square root of 5 times 5. We can simplify that even further with the 3 here. So it would be negative 3 times 41 times 5, which then would be equal to 205. 3 over 205. Square root of 205. Let's move on to the next relationship that can be observed between two vectors, which is the vector and scalar projection. So vector and scalar projection, these are its formulas. Visually, it can be seen like this. Let's say I have one vector here, vector B. Ito yung B natin. And let's say ito naman vector A natin. A vector projection would work as such. You would take a vector at the tip on B, and you would project it downwards until you hit vector A. Then the length of the vector from the origin, itong meeting point nilang dalawa, to that point where it projected onto A, that is your vector projection. Ito yung VP natin, yung vector projection. Additionally, makikita natin dito that yung scale nito, yung magnitude ng vector projection, it depends on the scalar projection. So if the scalar projection is greater than 0, it is on the same direction as A. If it's less than 0, it would be on the opposite direction as A. So it would look like this. This A, to see B. So B would project down to A, and your vector projection would point here. Cool. Let's try it out in this example ulit, yung AB natin. So A is equals to 4, 5. B is equals to 10, 5. And now we are trying to find out the vector projection. So as we established before, what is our magnitude of A is equals to square root of 41. Tapos A dot B is equals to negative 15. So our vector projection is equals to negative 15 over 41 times times the vector for 5. So this equals to negative 60 over 41. So naman 15 times 5, that is 75. Yeah, 75. So negative 75 over 41. And that is our vector projection. Yung scalar projection naman, it would just be negative 15 over square root of 41. We can rationalize this. Gusto nyo pa? 15 square root of 41 over 41. And this tells us that it is pointing on the opposite direction as A. Keep note na kapag nasusulat to in word problems, it is usually described as B onto A. Parang B, you put it onto the vector of A. And whatever is one being described here onto A, siya yung magiging nasa baba. Some properties lang of dot products. So as we can see here, it is commutative. Makes sense naman, no? Since if we look back dun sa formula ng dot product, it is x1, x2 plus y1, y2. Kapag binaliktad mo siya, it would still be the same value no matter what, diba? Additionally, you can distribute it since yun nga, it depends naman on multiplication. You can move around a scalar inside before doing the dot product. And if you wish to get the magnitude squared, it would just be a dot a. And if you do a dot zero vector, it would just give out 0. Since zero vector consists of 0 and 0, that would mean you're doing x times 0 plus y times 0, which is just equal to 0. Lastly, we are going to talk about vectors in space, or the third dimension, 3D vectors. So instead of just having x and y, we have an additional vector z. So far naman, the rest of the standard operations mostly follow yung same formula. When you're doing addition, you add the corresponding terms. Multiplication, you distribute the scalar onto each term. Computing for magnitude, you do the square root of the terms added together squared, the square of the terms squared, the square of the terms sum. Yeah. And for the dot product, you do x1, x2 plus y1, y2 plus x1 z1, z2. However, what is slightly different here is the directional angles. If you think about it, we only have one sort of relationship with direction when we are doing 2D. And that is the x and the y axis. And we get the angle between those. However, when illustrating a 3D vector, we now have 3 dimensions to work with. Let's say ito yung vector natin. And let's label this as, actually, it's better if I use something like orange here. Tapos, let's label this as x, y, z. If you notice here, we have 3 types of directional angles that we can observe. First is here to the z-axis. Second is here to the y-axis. And third is here to the x-axis. Therefore, we have 3 different types of angles that describe the direction of a vector, and these are called the directional angles. These are computed as such. Basically, alpha here is this, gamma is this, and yung beta is this. So it is just the corresponding component. So whatever is the component inside of your vector, so yung x component divided by alpha, yung y component of the vector divided by, not alpha, I mean the magnitude. Yung y component of the vector divided by the magnitude, and yung z component of the vector divided by the magnitude. That is the standard formula for directional angles. Lastly, we are going to talk about cross product. Cross product here, it is defined as the determinant of this matrix. It is only observed in R3, or yung mga 3-dimensional vectors natin. And yung easiest way to compute it for me would be to do the determinants. Okay? Let's say, let's try it out. Let's say we have 3, 4, 5. And for B, you would have 10, -1, 6. That's easy. So A dot B would then be equal to I, J, K, 3, 4, 5, 5, and then 10, -1, 6. We line up the vectors uh, on the first slot into the second row. Tapos for B, we line it up here. So third row. And now we just compute for the determinant. So ijk here, this is actually yung unit vector notation for R3. So I would actually be 100, J 101, K 001. So we are getting yung unit vector notation nitong cross product. The cross product would give out a vector. Yung vector niya, it is orthogonal to both A and B. So if tinanong ka, give me a vector that is orthogonal to these two vectors given below, then you should think right away we are looking for the cross product. So let's compute for the cross product here. If we would remember, it would be first we do this, yung determinant, right? Yung parang basic formula natin. So it would be 24 minus 5 times -1. So that's +1. +5 pala. +5i minus, then you would cross this out and then do it for j. So 18 minus 50 j plus for k naman, these two. So it would be -3 minus 40 k. And simplifying that, we get 29i plus 18 minus, that is 32. Yeah, 32j. Tapos minus 43k. And that is your cross product. Lastly, here are just some properties of cross products. So A cross A is equals to 0. If you think about it here, A, B, C. If you think about the determinant, how would you compute for the cross product as such? It would look like this. So you get yz minus yz. So it's 0. Ito naman, xz minus xz, also 0. xy minus xy. So that's 0. So that's why that happens. Similarly, ganun din, no? If we were working with 0 dot cross A, B0, 0, 0. So you are just multiplying everything by 0. And additionally, itong property na yan, we can see here that cross product is not commutative. In fact, A cross B is actually negative of B cross A. However, it is distributive. You can distribute it. You can also move around the scalar to group it inside of the different vectors. And finally, ito medyo special siya. A dot B cross C is equals to A cross B dot C. So when working with cross product and dot products, always do cross product before the dot product. Yeah, the cross product takes priority over the dot product. Remember that. So that is all for today. I hope you learned a lot, and I am Aaron Dichoso from the Peer Tutor Society, hoping and wishing that you have successful studies for today.